Hello, everyone. Thanks for joining. Good afternoon. This is NET301, extending data centers to the cloud. My name is Benjamin Feldon. This is Sid Chawan. Both Sid and I are solutions architects with AWS. We are based out of New York. Sid and I presented a talk with the same title last year. It was then labeled NET305. So today we'll be presenting an updated version of that talk. But since many new exciting releases from over the course of the last year, a lot has changed. So the session from last year can still be found online, both the recording as well as the slides. This is a 300-level talk. So our expectation is that you already have a grasp of VPCs and ideally have had a chance to configure some. Our goal in this talk is to discuss the different options that you have for creating a hybrid environment between what you have running in AWS and what you have in your data centers outside of AWS. So at the end of this talk, I hope that you leave here with a good handle on what are the options that there are for you to create that connectivity, and what are the architectural considerations that come into play when making those decisions for your business. Now, the connectivity options are changing, and so we've greatly developed the offering, which has opened up use cases that did not exist before. And so I hope that you leave here with a good vision of what it is that these new options are and how they could be relevant for you. I'm going to start with a very quick level setting of terminology. When we're talking about hybrid environments, we're talking about network infrastructure that connects between storage and compute footprint running in AWS and some amount of footprint that you have running elsewhere. So when you think about connecting a data center or a colo or a SaaS solution to AWS, there are many use cases that come to mind. So some examples are, you could be thinking about AWS as a reliable site for object storage, things like backup, archival, logging. AWS could be your disaster recovery site, offering you some geographic distance from where your applications are running in prod. Hybrid connectivity is almost always needed when you use workspaces as your VDI solution. So you have these virtual desktops that are running in AWS, but they need connectivity back to applications in your corporate data centers. There are different flavors of split architectures. These are cases where certain layers of an application are running in AWS, some layers of an application are running elsewhere. In that vein, some releases that we have made this year now allow you to run a load balancer in AWS, which has both AWS endpoints as well as IP-based endpoints. So there are a ton of use cases. Most of the customers that I speak to have a mixture of them. And so they need to evaluate each use case, what are the networking considerations that it has, and then adapt their connectivity to match. And that's where we begin to talk about the solutions that AWS puts forward towards making this connectivity work. So generally speaking, we have three main options. There's going over the public internet, there's creating a VPN connection, or leveraging an AWS service called Direct Connect. So going over the public internet is pretty straightforward, right? Our services have public endpoints. Your resources can have public IPs assigned to them. So our talk today is going to focus on the other two options. And so IPsec VPN is a technology that both authenticates and encrypts IP packets. In the context of AWS, this really breaks down into two main options. There's AWS Managed VPN, and then there's software VPN that's running on EC2. And we'll talk about the pros and cons of each. The other option is to use Direct Connect. Direct Connect is a service. You'll sometimes see this abbreviated to DX. It's been offered since 2011. And what this provides is private and dedicated physical links into AWS, which you achieve by connecting with us at one of 67 locations around the world. And that provides a consistent network performance. It would be private end-to-end, which means that traffic traverses the AWS backbone and not the internet, and so is not susceptible to internet weather type events. And then for this, we offer port speeds of 1 gigabit per second or 10 gigabits per second, or those sub 1 gig connections as well if you are using a partner. These slides show some of the Direct Connect locations that are available for you to connect through. These locations are these large co-location facilities where you are invited to come and meet us. Then once you are there, you can physically connect to AWS. You may have seen similar slides that we've shown in previous years, and if so, one thing that you'll notice is how many more locations there are now to choose from. If I add a representation of the regions, you'll see that the region in Canada is also new. And now the arrows represent how each Direct Connect location is homed to one specific AWS region. That is its local region. Here are some more of the locations, and again, you'll see how many of them are new. In fact, we've added 25 over the last year alone. And their regions, Seoul and London, are also new. And again, each location is home to one specific AWS region. Now, in the past, connecting through a location would provide access to resources in the region that the location was home to. That was true for VPCs as well as public IPs. Now, this paradigm still exists, but we've added a new one on top of it. And in order to do that, we've released a feature called Direct Connect Gateway, which opens up global connectivity to all of the AWS regions via each Direct Connect location. This is true with the exception of China. Now, you can still leverage the connectivity pattern without Direct Connect Gateway, which will connect your routers directly into your VPCs. But with that pattern, there is a one-to-one relationship between the location and the region that has opened up in terms of VPCs. So with this new pattern, by leveraging Direct Connect Gateway, when you connect to a Direct Connect location, you're effectively connecting to the AWS backbone. And that opens up VPC connectivity in every public region, as well as the public IP space of all of those regions. There are other advantages to using this, such as being able to connect to multiple VPCs over one virtual interface or one VLAN. And we'll get into that a little bit later on. Sid will walk us through the different architectures of this connectivity pattern. But for now, let's look again at the map slides and see what they should look like today. So again, these are the locations in North America. And this is how you can begin to look at Direct Connect connectivity going forward. If I remove for a moment the locations and we focus on one example, there's Equinix in Dallas, Texas. If you choose to leverage the Direct Connect Gateway, each location is now an entry to the global AWS network backbone over which you can connect to all of the public regions. Or as an example here, if we focus on the location in Perth, Australia, that one location could be an entry point to your entire AWS footprint. Via the backbone, it can connect to VPCs in Frankfurt or in Singapore or in Sao Paulo, etc. So this is a major and fundamental change in how we look at this service. But before we get into the specifics of how you gain access to resources, let's take a quick step back and talk about the different connectivity architecture options that there are. So we've already established that we have a requirement for hybrid connectivity, and we've noted that we'll be achieving it with either VPNs or Direct Connect. Let's begin to draw out what this looks like. On the one hand, you have your corporate data centers. On the other hand, you have an AWS region. And that has both one or more VPCs, as well as AWS services with publicly addressable endpoints. So these are things like S3 or SES or DynamoDB or SQS. Our conversation today is about how do we connect these two things together, so I'm going to move them aside, and we can focus on what's going on in between. We'll start with discussing the two VPN options that I mentioned before. And the first one is AWS Managed VPN. When you use this option, AWS will fully manage the VPN termination endpoint on the AWS side. And we call that side of the tunnel the Virtual Private Gateway, or VGW for short. And similar to other managed services, this means that AWS takes care of all of the underlying infrastructure, as well as high availability. So it's a region-wide, highly available resource, which means it can sustain an availability zone failure without performance degradation. And we call the customer side of the connection the Customer Gateway, or CGW for short. And the CGW represents the hardware or the VPN that terminates VPN on the customer side, on the remote side. Managed VPN supports the latest features and standards that you would expect from a VPN vendor. It's extremely simple and quick to set up a VPN connection this way. You'll use the management console or make an API call and create a VPN connection. And we try to make things very simple by allowing you to download a configuration that you can then go and apply on your device. And for that, we support vendors like Cisco or Juniper or Fortinet. That doesn't mean, though, that if you don't see your vendor listed there, the connection won't work. It just means that you will have to download a generic configuration, adapt it, and apply it on your device. Once you've applied that configuration on your device, you should be up and running with a working VPN connection directly into your VPC. And then routing on top of that can be done either statically or using BGP. Now, if you look closely at the configuration that you've downloaded, you'll see that the VGW is represented by 2 separate publicly addressable IPs, and that's how high availability is achieved. This is the behavior by default. When you bring up that connection, it will consist of 2 tunnels. It's not a configurable thing. That gives you an idea of how seriously we take high availability. The cost that's going to be associated with one connection will include both of those tunnels, whether you use that second one or you don't. You don't have to bring up that second tunnel in order for the connection to work, but if you're looking for a multi-availability zone, highly available connection, we recommend that you do. We also recommend that you think about resiliency on the remote side. So if you can, you should allocate a separate device for the purposes of high availability, and now you bring up a second VPN connection from that second CGW into the VGW of your VPC. Each of those will have 2 tunnels, and so there'll be a grand total of 4 when you leverage high availability on both ends. Once both of them are established, traffic will begin to flow through one of them, and you have the ability to influence which one of them that is in both directions. You do that with BGP, and that is influenced on a per network basis. They won't both be used, though, at the same time to access the same network. So think about this as an active standby configuration. So now we know what's involved with setting up a connection for one VPC. If you wanted to connect to a second VPC using VPN, you have to repeat the same steps. And you start by creating a second VGW for that VPC because they are unique per VPC. And then you create 2 VPN connections towards that second VGW, probably reusing the same CGWs. And so there will be 4 tunnels for each and a grand total of 8. And of course, you may want to connect to more than 2 VPCs, and so these are the steps that you need to repeat. This is how I'm suggesting that you think about connectivity options. It's by looking at it with these dimensions: flexibility, cost, resiliency, and performance. So in that context, AWS Managed VPN is very simple, very quick to set up. It offers the latest security as well as BGP routing. You get out-of-the-box HA, although we encourage you to think about high availability on your end as well. You pay 5 cents an hour for each VPN connection, which will include those 2 tunnels. And you can get up to 1.25 gigabits per second, but that's limited at the VGW, which means that all of the VPN connections to that VPC share that bandwidth. These are some of the highlights of what is new with AWS Managed VPN from the course of the last year. So just to call out a couple of things which you may have missed. You can now bring your own autonomous system number, your ASN, to the AWS side of the connection, as opposed to just accepting ours. The pre-shared keys used to establish trust can now be configured, as well as the IPs inside of the tunnel. And we've added CloudWatch metrics so that you can monitor and alert on your connection's activity. So the second option is to use software that's running on EC2. This is when you create a virtual VPN appliance to terminate the VPN connection on the AWS side. We typically see customers doing this if they're trying to stay uniform with their VPN provider of choice across all of their sites. Or if they're trying to use a vendor-specific feature like a Cisco DMVPN or a Sophos UTM suite, so a specific routing protocol or a security feature that sits on top of the tunnel. In order to get this up and running, you need to instantiate an EC2 instance, connect the VPC to an internet gateway, make sure that the instance is reachable via an elastic IP, and then you install the VPN software. So this can be a commercial product, like a Cisco, like a Fortinet, or it can be an open source product, like an OpenSwan or an OpenVPN. You can actually one-click deploy VPN software from the AWS Marketplace, which will make this a lot simpler. Now, in this scenario, you're establishing your VPN connection directly into the VPC, into that instance, and so the VGW does not come into play at all. And unlike managed VPN, it is now the customer's responsibility to maintain high availability and scale. And so you will need to instantiate a second VPN appliance in a second availability zone for high availability. You'll also need to build some fairly simple automation, or some of these vendors have already published their own, so that if a failover is needed, the VPC route tables get automatically updated to send traffic to that second VPN appliance. There is going to be a little bit of a lag time that's involved with that. We see failover times that are slightly longer with this option than the managed VPN option. If I summarize this option, this is where you're deploying VPN on EC2. It can be an open source or a commercial solution. This can be leveraged in advanced architectures like the transit VPC, which is a topic that Sid will expand on later a little bit. It's the customer's responsibility to maintain high availability and scale. Here you are paying for the EC2 instance hours, and depending on the VPN software that you've chosen, there may be vendor licensing. And your bandwidth is going to be a function of which EC2 instance type and size you've chosen. So if you choose one of the beefier instance types, you can get multi-gigs per second from each instance. OK. So we have an understanding of the two VPN options. I want to start talking about Direct Connect. And the conversation here starts with an ask from our customers that they be able to truly leverage their cloud resources in the same way that they do between their different data centers, which requires a private end-to-end connectivity entirely disconnected from the internet, and so a consistent network experience. How does this service work? You can find the list of locations that are available in the product's details page. This is a list of locations. If you remember from the map slides that I showed before, they are these large co-location facilities that we are already established in. And what that means is we own and operate devices in cages that belong to AWS, and we've connected between them to our backbone. Keep in mind, these locations are not where the region is. They're not where a specific availability zone is. They're external to the region. So once you've identified which location you'd like to connect through, you need to establish the physical connectivity. And this is an area where there's sometimes a little bit of confusion, so I want to dig into that. There are essentially 3 different connectivity scenarios. And the first one is relevant if you have presence in that co-location, in which case Direct Connect cannot be simpler. You simply log on to your account, create a Direct Connect connection, and that represents a physical port. You need to tell us which location you're in, and if you're interested in a 1 or a 10 gig connection. And that's it. Those are all of the questions that you need to answer. That will trigger a process at the end of which you can download an LOA, a letter of authorization. This LOA means that we have allocated a port solely for you on our devices. You are now authorized to connect to it whenever you're ready. At that point, you take that LOA, you give it to the colo provider, and you request a cross-connect between your router and our device. Once that cross-connect is established, you are physically connected to AWS. And you can now start connecting to resources. But we'll get to that bit later on. The second scenario is, what if you don't have presence in a co-location? That's not a problem. You will need to engage with one of our partners or a network provider to build out a circuit between your data center and that co-location. You'll go through the same process that I described before. You tell us if it's a 1 or a 10 gig port. But now you take that LOA and you give it to the network provider, and they request the cross-connect on your behalf. We have a list of APN partners that are supporting Direct Connect that is available online. These are partners that are well-versed in building out circuits into some or all of the Direct Connect locations. But if you're already working with network providers, even if they're not on this list, talk to them. Ask them if they're able to build you such a circuit into the location that you've chosen. So what's going on behind the scenes in this scenario is that these partners have some piece of equipment at the co-location, and they extend layer 2 connectivity between your data center all the way to that port, the one that's mentioned in the LOA. Now, you may recall that before I mentioned that we also offer port speeds of below 1 gigabit per second. It is in this scenario where that option fits in. Only if you're using a partner, you can also order connections with a port speed of 50, 100, 200, 3, 4, or 500 megabits per second. Keep in mind, though, that if you are using that option, the sub 1 gig option, you will only be able to create one virtual interface on top of that. That's going to make a little bit more sense when Sid talks to us about virtual interfaces, so keep that in the back of your mind. The third scenario is relevant if you're already engaged with a service provider that's running a managed network that's connecting your different locations, and you now want to extend that managed network to include AWS. The underlying technology could be MPLS, it could be some other backbone service. You may recognize brand names such as AT&T NetBond, Verizon SCI, Level 3 Cloud Connect. These are solutions that fall into this category. And these providers typically have their own Direct Connect in their own accounts, and they connect between your data centers and your VPCs on top of them. As you're making these decisions on how to physically connect, I want you to keep in mind these considerations. In whose account will the Direct Connect port be created? So depending on the scenario that we just talked about, if you're using a partner, ask them. They may be using their own, or they may be asking you to create it in your account. Which leads us to the next consideration, which is, what then does the process look like for creating additional virtual interfaces for the purposes of connecting to additional VPCs or additional accounts? Who is responsible for the routing between the corporate networks and the AWS networks? And what are the costs that are associated with this connectivity? So the best recommendation that I can give about all of that is, if you don't already have presence in one of those locations, talk to the network providers that you're currently engaged with and ask them what they can offer you in terms of getting to the location that you've chosen. Ask them these questions so that you understand exactly what's being offered. And I also recommend that you loop in your AWS solutions architect. So these are folks like Sid and myself, and have him or her participate in the conversation where you're debating these different options. Now, I've already brought up cost. I want to discuss a couple of finer points here. You may be aware that data that's flowing into an AWS region is always free. The data flows that are charged are for egress. So data egress or data out over Direct Connect will be less expensive than over the internet. When I say over the internet, I mean the pricing that is in effect when data is flowing out of a VPC or out of the region over the internet, whether it's VPN'd or in the clear. When you're evaluating the Direct Connect costs, you need to not only think about the data out, the data egress, but also the port hours, and that will depend on the port speed that you've selected, as well as what was involved with getting to that location or establishing your physical presence there. Now, you may be wondering, now with Direct Connect Gateway offering me connectivity to regions all over the world through the backbone, how is that priced? So this is a table from the Direct Connect pricing page that kind of explains how this works. So as I mentioned before, data that's going into a region is not going to be charged, and that is regardless of what that destination is. So let's think about that for a moment. That's a major advantage to using the AWS backbone, right? Because if your use case is very heavy on ingress, there are significant cost savings to be had by leveraging the backbone for as much of the distance as you can. And then for data egress, the Direct Connect locations are grouped together. So for example, all 28 of the locations in the United States have the same data out costs associated with them. The regions are also somewhat grouped together. And so consulting with this pricing page, you can get a sense of what is going to be the cost for getting data out. So as an example, let's say that you have data that's flowing out of your VPC in the Singapore region. That falls under the Asia Pacific group. And let's say that you are connected using Direct Connect in Equinix in Frankfurt. That falls under Europe. And so the price will be 9 cents per gig. And that kind of leads me to the next question, which is, how do I choose the right location to connect through? So certainly cost will be a factor in that, right? There's the egress pricing, which we just figured out. There's building the circuit or establishing the colo presence. So I'm calling all of this end-to-end costs. Another factor is going to be latency. That should play a major role in you making this decision. And you can actually connect with your AWS account team and work on figuring out some estimated latency times between a specific region and a specific location. And then finally, how are you connecting to that location from your data centers? Does that meet your performance, resiliency, and cost targets? So now we kind of know what are the physical connectivity options. How should we think about cost? Let's talk about resiliency as it pertains to Direct Connect. Let's assume that you have presence in one of the colos, you've completed the cross-connect, you are now connected between one port on your router and one port on our device. Earlier this year, we launched support for link aggregation groups, or LAG for short, which means that you can now group together several physical connections and treat them as one managed single connection. You can bundle up to 4 ports of either 1 or 10 gigs. That's actually one of those limits that you can ask to increase. So as an example, let's say that your connection, your circuit between your data center and the location can support 40 gigabits of bandwidth. If you order 4 10-gig ports, you can group them together and deploy virtual interfaces on top of them as if they're one connection. Keep in mind, though, that they connect to one device on the AWS side. And that kind of brings us to the next question, which is, let's put aside lag for a moment. What does all of this look like in terms of resiliency, in terms of susceptibility to failure? If we think about the physical elements that are here, we can point to potential points of failure. The customer router connected by a single port, a single cross-connect, into a single port on the AWS device. You may be using lag for performance, but that connects to a single device. Now, that piece of hardware is connected redundantly to the backbone, but up to it, there are fiber optics, line cards, power supplies, software. So all of the things that you would concern yourself with when connecting between your different data centers, they still apply here. And what is our goal? Our goal is to design connectivity that matches the level of resiliency that you have in your AWS workloads, right? So your AWS workloads are probably architected in a multi-AZ fashion. They're attempting to avoid any single points of failure. So let's consider VPN as a backup. This is very simple to set up. The cost isn't going to be bad at all. When you use the AWS Managed VPN option, we will automatically favor going over Direct Connect as opposed to VPN when both of them are available. So inherently, we treat this as a backup solution. But VPN may be less performant, will likely be not as consistent in terms of the network experience. And so you need to think about, is this acceptable connectivity for the duration of time while my Direct Connect is being fixed or while my circuit is being worked on? So one notch up in terms of resiliency is another Direct Connect link. When you order a second connection from the same account in the same location, we will automatically place you on 2 different pieces of hardware. And that will provide device redundancy. You've gained device redundancy on the AWS device, but you'll likely want to do the same on the customer device. And so you may want to add another router in your cage or build out a second circuit from one of your data centers. Now, as soon as we start talking about 2 Direct Connect ports accessing the same networks, we should talk about how they're used together. Remember, though, this is not link aggregation because they are connected to 2 different pieces, 2 different devices. They're not grouped together. So by default, we will multipath between them, which means we will use both of them at the same time. And so effectively, this is an active-active configuration. 2 10-gig ports will provide 20 gigabits of bandwidth. But there are cases where customers choose not to do this. And they configure things in an active standby configuration. We typically see that if they have a stateful firewall and they're trying to avoid asymmetric routing. But in this scenario, you can influence which one of these links is preferred. You do that using BGP AS path prepending and with local routing decisions on your device. So you can set the preference of which one is used. Now, while these two devices are separate pieces of equipment, they are in the same physical location. So if the workloads that you are supporting are designed to span multiple availability zones in AWS, or in other words, they're designed to withstand a facility-wide failure, you haven't matched that level of resiliency in your connectivity architecture by connecting two connections to the same location. And now with Direct Connect Gateway, this could be your entry point to your entire AWS footprint, and so that becomes even more concerning. So the answer to that problem is to build that second Direct Connect link via a second Direct Connect location. And that will provide full facility redundancy. If you remember the map slides that I showed before, there are a lot of locations to choose from. That's how you go about adding that layer of resiliency. So as an example, if your data centers are mostly located in the northeast of the United States, you may want to build your first circuit through Equinix in Ashburn, and maybe that second one using CoreSite in New York or in Reston. So now we're on a properly designed, fully redundant architecture that's designed to withstand up to a full facility failure. But for good measure, we still recommend that you add a VPN. And this VPN, again, will not provide the same connectivity, the same experience, but it is there as a second layer of redundancy. So regardless of which resiliency methods you choose to employ, I strongly recommend that you test failure scenarios and that you do so on a periodic basis. So if I review Direct Connect as a whole, this is a service that's offered to every public region through 67 locations around the world. Expect to be able to download your LOA within 72 hours, although it typically takes much less. Building out a circuit, building out a presence in a colo will take longer than that. When you think about resiliency, think about VPN, think about adding a second Direct Connect link. Ultimately, think about a second Direct Connect location. Your cost is going to be a factor of the port hours, the data out, which is going to be less expensive than over the internet, and any provider charges. And performance is going to be either 1 or 10 gig, depending on what you've chosen, or those sub 1 gig options if you're using a partner. The more connections you add, the more bandwidth. So I also want to call out what is new with Direct Connect from the course of the last year. So first of all, we offer many new locations, as mentioned a couple of times. This list is always expanding. And in fact, if you go to the State of the Union on the networking track today, you may hear about some more locations that are being announced. Similar to AWS Managed VPN, you can now bring your own ASN to Direct Connect. That's true for private ASNs, not public ones. CloudWatch can be used to monitor Direct Connect connections. We support IPv6. You can link aggregate a bunch of connections together now. And finally, Direct Connect is now a HIPAA-eligible service. So I'm now going to hand this over to Sid to talk to us about what are we actually connecting to.
So now that we know what our options for connectivity are and how to layer resiliency into an architecture, let's see how to gain access to resources over these connectivity options. Let's start by talking about AWS Managed VPN. When you create an IPsec VPN tunnel to your VPC, you can access resources inside the VPC using their private IP addresses. This includes EC2, RDS, Lambda, Redshift, and many more such services. But there are exceptions. You cannot access the network load balancer, Elastic File System, VPC endpoints, including the recently released private link endpoints, are not accessible. The VPC's DNS, private DNS, is also not accessible. And just to be clear, this is just for the VPC and not the resources sitting outside the VPC like S3, DynamoDB, which are in the public AWS IP range. Now let's talk about Direct Connect. Benjamin mentioned that we recently released Direct Connect Gateway, which gives you access globally to all AWS regions except China. But I want to take a step back and see how things worked prior to its release when you connected directly to the virtual private gateway. It is important to understand how that works because that model is still supported today. And I'm sure many of you are still architected in that fashion. Once we look at that model, then we'll go talk about Direct Connect Gateway, see what the differences are between them so that you can go about leveraging the newer model. So let's start with talking about the previous model. Let's say you have an AWS infrastructure which consists of multiple VPCs, prod, test, dev, VPC. They are isolated in their own accounts. Now, in order to access resources, you need to create a virtual interface. For a VPC, it's called the private virtual interface. While doing so, you have to specify which virtual private gateway and which VPC you want to connect to. You also have to specify a VLAN ID. Now, all traffic which is destined to this VPC should be tagged with this VLAN ID by our routers as the traffic is being sent to the AWS Direct Connect devices. Over this VLAN, a eBGP session gets established. Over the eBGP session, AWS devices will advertise to you the VPC CIDR range. And what you advertise to us is up to how you configure BGP at your end. But remember that VPC has a limit of 100 routes when it comes to dynamic routes. And that limit applies to Direct Connect as well. So you might want to summarize your routes or even advertise a default route if that fits your use case. Configuring all of this is pretty simple. When you create the private virtual interface, AWS N gets auto-configured, and you get an option of downloading a configuration file, which you can go and apply on your router. Now, you repeat this process for every VPC you want to connect to. So it's a different VLAN, a different private virtual interface, and a different BGP session for each VPC. Now, for resources outside the VPC, you create what's called a public virtual interface. This will coexist on the same Direct Connect port, but it will have its own VLAN ID and its own BGP session. And as part of BGP route advertisements, we will advertise to you AWS public IP range. So that was how the VGW-based model worked. So let's see how things work now that we have released Direct Connect Gateway. So let's say you have AWS resources in US West Oregon region, which consists of an app1 VPC, and you want to connect to this resource through the SuperNAP Las Vegas facility. So now you create a Direct Connect Gateway as step one. Next, you'll create a private virtual interface, but now instead of the virtual private gateway, you terminate it on the Direct Connect Gateway. It's still the same process around VLAN ID, BGP sessions. Next, you associate your virtual private gateway to this new Direct Connect Gateway, and that's it. Now the Direct Connect Gateway will start advertising the CIDR range of that VPC to your routers, and hence you can go ahead and access it. Now, if you had a second VPC for app2, you would simply associate the virtual private gateway of that VPC back to the Direct Connect Gateway. And now, through BGP route advertisements, Direct Connect Gateway is going to advertise the CIDR range of both VPCs, and you get access to both. Now, let's say you had a DR VPC for your app1 in the Singapore region, and you wanted connectivity into that. Simply associate the virtual private gateway of this new VPC in Singapore back to the same Direct Connect Gateway. You can already see a difference. Through one private virtual interface, one VLAN, and one BGP session, you are able to access VPCs globally. Now, leveraging the Direct Connect Gateway, you can access resources in the VPC using its private IP addresses, and this includes EC2, EFS, NLB, RDS, and many more such services. And this VPC can be located in any AWS region. So now you have your own global private network in AWS, which is now acting as an extension of your data center. So now that we understand how both models work, let's do a comparison of what the differences are. On the top, you have the VGW-based model. where you create one private virtual interface per VPC, giving you access into resources in the AWS region with the Direct Connect location is home to. Below, we have the Direct Connect gateway-based model, where you create one private virtual interface, but this gives you access into VPCs globally over one VLAN and one BGP session. Now, there are a lot of similarities between the two models. So the process of creation of private virtual interfaces and ordering new Direct Connect circuits is still the same. The AWS resources which you can access inside AWS, EC2, NLB, all of that remains same. The resiliency model, which Benjamin talked about, having multiple Direct Connect locations, that still remains the same. And finally, the VPC route limit of 100 for dynamic routes, that applies to both the models. Now, we were talking this in the context of a single account. So let's see how the multi-account model works with Direct Connect Gateway. Now, this is the infrastructure we had set up previously. Now, let's say if we isolate the two application VPCs into their own accounts. Now, Direct Connect circuit can be used to access resources in multiple accounts. But Direct Connect Gateway is a resource local to an account. So if we put the Direct Connect Gateway here in the app1 VPC, as such, you cannot connect app2 VPC to this Direct Connect Gateway. So you'll have to create a new Direct Connect Gateway in the app2 VPC. You can create a private virtual interface and push it into this second account, and then associate the app2 VPCs and any other VPCs in that account to that Direct Connect Gateway. So in essence, you will require one Direct Connect Gateway per account, and that will give you access to the VPCs in that account. Now, you might be familiar with the concept of VPC peering, which allows two VPCs to communicate with each other. Now, let's say we have a shared services VPC and a production VPC, which we have set up, and we have peered them together. Let's see how this works with Direct Connect Gateway. So if you set up a private virtual interface into the shared services VPC and you wanted to leverage the Direct Connect Gateway as well as the VPC peering to access resources in the prod VPC, this is transitive routing, and VPC peering does not support it. So this model does not work. You will have to associate the virtual private gateway of the prod VPC directly to the Direct Connect Gateway and access it natively that way. Now, about 2 years back, we released VPC private endpoints. VPC private endpoints gives you access into AWS resources sitting outside the VPC, like Amazon S3, and we recently added support for DynamoDB as well. That feature is now renamed as Gateway VPC Endpoint. So if you have a Gateway VPC endpoint attached to your production VPC, and you wanted to leverage Direct Connect Gateway, as well as the VPC endpoint to access your resources, this again is transitive routing and is not supported. So you cannot access Gateway VPC endpoints over Direct Connect. You can, however, build a fleet of proxy instances in your VPC and proxy all traffic from your on-premises networks. But be mindful that you need to configure your on-prem devices to use this proxy, so this is not a transparent process. Now, we also recently announced interface VPC endpoints. Interface VPC endpoints gives you access to AWS services like Amazon Kinesis, Elastic Load Balancing APIs, EC2 APIs, and this works a little different. Interface endpoints appear as a network interface inside your VPC and gets an IP address from your VPC CIDR range. Now, if you wanted to access these interface endpoints from your on-premises networks through the Direct Connect private virtual interface, this is supported. So you can access these interface endpoints over Direct Connect. As part of the new launch of Direct Connect Gateway, we also introduced a change to how a public virtual interface works. Now, if you had a public virtual interface set up, earlier it used to give you access to the AWS region it was home to, but now it gives you access to all AWS resources globally. And here we are talking about non-VPC resources like S3, DynamoDB, EC2 public API endpoints, and EC2 public APIs, IP addresses. Now, as part of the route advertisement, we will advertise to you the entire AWS CIDR range, public IP range, and this includes over 2,000 prefixes. So this might get a little overwhelming, and you can actually go and check this link. That's where we list all the IP addresses. So we do make it possible for you to filter out some routes, and you can do it in two ways. So first is based on the geography. So you can say, I want to filter out routes or accept route only of the region that my Direct Connect location is homed to. Or you can say, I want to accept routes of only those AWS region which are in the continent that my Direct Connect location is home to. And you can do that using BGP communities. The second option is to filter out using AWS services. So if you look closely at the JSON document which contains all the IP addresses, you'll see that we list out prefixes based on AWS services. So you can say, I want to send traffic only to Amazon S3, and you can use this information to do that in your routers. Now be mindful that currently we only give out this distinction for S3, EC2, CloudFront, Route 53, and code build. When creating the AWS Managed VPN, Benjamin mentioned that we give out 2 IP addresses for high availability. These are public IP addresses, and these addresses are part of the IP range which we advertise over public WIF. So what this means is that now we can access these IP addresses over the public virtual interface. And we can use this to our advantage. So instead of connecting to the VPC through the Direct Connect gateway, we can create AWS Managed VPN IPsec encrypted tunnel, and this traffic will flow over public virtual interface. Now, if you have compliance requirements which requires end-to-end encryption, and your application is not using TLS SSL, then you can consider this option. Now, I hope you have a good understanding of sort of how the Direct Connect gateway model works. But before we wrap this topic up, I want to talk about some key considerations. So let's say you have an AWS global infrastructure with VPCs spread across multiple AWS regions. To gain connectivity into this infrastructure, you set up 2 Direct Connect gateways with private virtual interfaces into both. Now, if you wanted to route between 2 VPCs using the Direct Connect gateway, this is not supported. Direct Connect gateway cannot route between 2 VPCs. It cannot peer 2 VPCs. It is only meant for hybrid traffic, so for traffic between your data centers and the VPC and vice versa. If you had 2 VPCs with overlapping IP addresses, you cannot attach them both to the same Direct Connect gateway. If a VPC was already attached to a Direct Connect gateway and you try to attach it to a second Direct Connect gateway, that is also not supported. So you can have one VPC attached only to one Direct Connect gateway at a given point of time. Now, in this slide here, the US West to Oregon VPC is directly connected to your routers through the private virtual interface using the VGW-based model. So if you have that connectivity today, you cannot attach your VPC directly to the Direct Connect gateway. So you can leverage either the VGW-based model or the Direct Connect gateway model, but not both at the same time. Now let's switch gears a bit and talk about something which is very relevant to our customers today. since we have heard a lot of feedback from you guys that you had use cases which were not met by the native way of accessing resources over Direct Connect and VPN. So let's look at what those concerns were, or concerns are. So customers are connecting their VPCs to remote networks, which they don't trust, and hence they want to implement this layer 7 security stack for all hybrid traffic. And they don't want to do it for every VPC that they have in their AWS infrastructure. They want to do it at a centralized location. Now, unfortunately, both VGW and the Direct Connect gateway don't support layer 7 filtering, although you still have layer 4 filtering using security groups. And if layer 4 filtering is your use case, then you should be using that. We also heard complaints that customers were connecting to SaaS providers and third-party vendors who had overlapping IP addresses, and there is no easy way to handle such situations. Benjamin mentioned that when you're using AWS Managed VPN, you have to create 4 VPN tunnels for every VPC you connect to. Now, as you grow into number of VPCs, creating more and more VPN tunnels might not be as agile as creating new VPCs, especially when you're considering change management processes and the approvals required to make configuration changes to on-prem devices. So from those requirements emerged the transit VPC architecture. The whole idea is that you'll connect remote networks and transit all the traffic through a pair of EC2 instances. Now, this is not an AWS service. It's an architecture which is built using AWS services. So here we leverage both AWS Managed VPN as well as EC2 software VPN to build this transitive architecture. So you have 2 spoke VPCs here. You have a spoke VPC A and a remote customer side, and you want to send all traffic through a pair of EC2 instances. So we create VPNs from the BGWs of the spoke VPCs to the transit EC2 instances sitting in the transit VPC. Now let's see how does this look sort of at scale. We have a transit hub VPC where we have a pair of EC2 instances. We have a bunch of spoke VPCs, and these spoke VPCs can be located anywhere in any AWS region. We set up a mesh of VPN tunnels from the spoke VPCs to the transit EC2 instances using AWS Managed VPN. The transit hub VPC has connectivity into non-AWS, non-VPC resources like S3 and EC2 using VPC endpoints. You connect your remote office through VPN, and you connect your corporate data center through Direct Connect, leveraging the detached BGW. Detached BGW is a BGW not attached to any VPC, and it can be used to bridge the Direct Connect and the VPN infrastructure. Now, with this architecture, we are able to fulfill those use cases. You now can just set up a pair of VPN tunnels from on-premises to the transit EC2 instances, and as more and more VPCs are deployed, they just create tunnel to this EC2 instance, and all that VPN creation is handled in the AWS infrastructure using automation. You can implement L7 security stack on the transit EC2 instances. The transit EC2 instances can also do NAT and hard IP addresses in case of overlapping IP ranges. They also provide access to VPC endpoints, which were not otherwise accessible over VPN. And this infrastructure can span the globe, so you can build your own global VPN infrastructure. Now, a few things to remember around this architecture. We are using a pair of EC2 instances for high availability, and these instances are in different AZs. We are using BGP for all the routing and failover, so that's very important. We recently published a solution on our website which leverages Cisco CSRs and Lambda functions for automation. So do check that out. Several third-party vendors have similar solutions published, like Cisco, Juniper, Aviatrix. And you can also use open source software like OpenSWAN, OpenVPN to implement something similar. Now, if you have transit VPC architecture set up, it does not mean you always use it. So if you have traffic between VPCs which does not meet those criteria, so you have two VPCs in similar trusted zones, you don't have to send traffic between them through the transit EC2 instances. You can still leverage VPC peering without breaking the architecture. And in this scenario, VPC peering is preferred over the transit EC2 instances. Similarly, if you have traffic which is initiating from your data centers destined to a VPC which does not fall in any of those use cases, again, you can leverage Direct Connect Gateway and access the VPCs directly, bypassing the transit EC2 instances. Keep in mind that transit EC2 instances have limited bandwidth, and you are managing them on your own, so the less you use them, the less you saturate them, the better. Now, at a global level, let's see how this works. You have a transit hub VPC in US East, connecting to VPCs all over the world. Now, if you see in this picture, the VPC in India and VPC in Europe have to come all the way back to US East to communicate. Now, if those VPCs are really chatty, you don't want that. So what you can do is you can create a local transit VPC in that part of the world, connect the two VPCs in India and Europe to that transit VPC, and then bridge the two transit VPCs together. That's how you would scale at a global level. So I hope this gives you an idea of how transit VPC works and sort of how you can leverage that. I'll hand it over to Benjamin to wrap it up.
So I want to go back real quick to what we set out to do in today's talk. We compared and contrasted AWS Managed VPN and Software VPN. We talked about Direct Connect and how that requires to first identify which locations you want to connect through and solve that physical connectivity with the right scenario. You want to think about resiliency. Factor in the recommendation that we made to use 2 Direct Connect locations for full facility redundancy. And then you begin to layer on top your logical connections to resources. So that's how you begin to support the workloads that you have running in AWS. Think about those workloads in these dimensions. Think about them in terms of flexibility, cost, performance, resiliency. How much bandwidth does each use case need? How do you estimate their data in and their data out? How sensitive are they to a break in connectivity or a degradation in performance? And then based on that, you make an actionable plan. I can't stress enough the importance of not just designing for resiliency, but also testing it out. Please don't skip this part. And do so on a periodic basis. I hope that we've given you some food for thought when it comes to the newly available features and architectures. So between the Direct Connect Gateway and Transit VPC, there are now use cases or architectures that didn't exist before, and they speak directly to requirements for global reach to regions all over the world. With things like lag, interface endpoints, IPv6, these are things that should help simplify how you do things. And finally, talk to your AWS team, your account managers, your solutions architects, your technical account managers, and loop us in so that we can help you make informed decisions. With that, I want to thank you all. And please remember to fill out your feedback forms. It helps us improve the content. These are sessions that you may want to check out later in the track. And thank you very much.